to the School of Code. It's time to resume our learning on Zoom. Get out the breakout rooms and get together.
Hello, and thank you for joining us here today. We are the Code Goblins, and we are here to show you our project recap. So, I'm Dan, a paleontology graduate who works in libraries. There I help people with their tech problems. Now I want to take that to the next level with School of Code.
Hi, I'm Piper, and I'm a never-ending work in progress. I've been a freelance illustrator for the past 5 years, working on everything from children's books to graphic design. I've always been fascinated by code, and after deciding that freelancing wasn't for me, I'm changing my career, and that's why I'm here at the School of Code.
Hi, I'm Aftab. For the last 15 years, I've been a leader in charities and purpose-led businesses. Throughout that time, I've been interested in tech for good, and I joined the School of Code to learn how to build purpose-led tech.
My name's Will. I was previously an infrastructure engineer for many years. I've dabbled in programming languages since my early teens, and I'm at the School of Code to upgrade my amateur skills to professional ones.
Hi, I'm Anna. I left my degree in medical physiology to live the dream working in admin, but surprisingly, that's not as fun as it sounds. So I went looking for a challenge and I found the School of Code.
Hi, I'm Dan. I was a personal trainer for 12 years, mainly helping people on a one-to-one basis. I joined the School of Code to get into a career in tech to hopefully help people on a larger scale.
So here is the problem we were given. How can our client, the School of Code, better deliver lecture resources to their users, the bootcampers? To better understand this problem, we looked into how the client currently delivers those resources, as well as the experiences the users had consuming them. We did this using questionnaires and interviews with both the client and a portion of their user base. The data we returned from this research found that the current process for delivering these resources is fairly basic, as it is just a list of video titles. The users often complain that they can't find specific resources that they might want, for example, lecture slides. All of the resources are scattered throughout the internet in different places that aren't clearly linked, making it inaccessible, and in some cases aren't available at all. Unfortunately, these things are deterring a lot of users from using the resources, and that's overall affecting their experience in the bootcamp. So a lot of users would benefit from more longer form content being broken up into smaller sections, have it collated into a more manageable experience, and just have a bit of a more central hub to easily search the content.
So as Piper said, we examined the current solution that's provided to bootcampers, which is the SOC video viewer. But we also explored similar solutions that are already available on the market, like Udemy and Blackboard. Udemy is a video learning platform, and the videos are really nicely organized by tags, and it's really searchable. Blackboard is used by a lot of unis to collate all the learning resources into one platform. So you'll have your lecture recordings, your slides, any workshops or tutorial information, but it's not searchable and it's a little bit old-fashioned the way it's laid out. So we wanted to take a little bit of inspiration from the good parts of these other examples and use them in our project. So Dan is going to start us off with our actual tech demo.
So I'm going to take you on 2 journeys of our app recap. First journey will be that of Jill, our bootcamper, and then secondly that of James, a School of Code coach. So Jill, as a bootcamper in week 12 of the bootcamp, decides she wants to revisit a lecture from a previous week. So she comes along to recap, where she logs in, where she's brought to our homepage. So from here, Jill is free to browse all the videos and content that has already been uploaded, or she can use our search functionality to find a specific lecture. So Jill knows the lecture she wants to revisit is on Use Reducer. So using the search bar at the top, she can find the specific videos there. As well as this, Jill could use our tag system on the left-hand side, as well as the local tags with each video. So knowing that the video she wants to watch is on Use Reducer, she also knows the lecturer of that video was Teo. So she selects Teo's name in the lectures coach, and we're left with the video from there. So once entering the video viewer page, Jill is free to rewatch the whole lecture if she decides, or she's free to use our timestamp system here, which will skip through the video to points that have been highlighted by the coach as specific, that are specifically useful from there. Along with the lecture itself, we have resources such as GitHub links, Google Slide documents, and any other, say, useful websites, all provided that go along with that lecture. Once finished, Jill is free to leave feedback anonymously, which will then be sent to our database, ready for the coaches to review at their convenience. From there, Jill's free to go back to search for another video, or she can log out if that's all she needed to do. We'll now take you on the journey of James, our School of Code coach.
So James has been a School of Code coach for about a year. What he intends to do is log into the system and manage some of the videos. He wants to add a lecture. Logs in and he can go to the content management section of the application, which allows him to add and remove videos from the site. What he wants to do here is add a video based on Node and Postgres. So he can have a look through the videos which are presented and uploaded to Vimeo and find that video. He finds that video here. You can click on the video and view it, make sure that its content's okay and view any details on it. And then when he's ready, he can hit select and add that video into the form on the right-hand side. He goes to select his name from the list, but it hasn't been added. So he can go into the tools menu and then he needs to add his name here. So he goes to put it into editing mode and he's going to add his name at the top there. And then he also notices that one of the other coaches' names has been spelled incorrectly. So he can adjust that and then save those changes as well. Once he's finished there, he's able to select his name from the list, and then he goes to add the tags to the video, which enables searching of it. The first one is Node, and the next one is Postgres. And unfortunately, a Postgres tag doesn't exist. So he heads to the menu, and he goes to the tag editor this time. Again, he puts that in editing mode, puts a Postgres tag in, and that will now be an available tag for him to choose. He also notices that there's a tag which has been duplicated here and spelt wrong. So he can remove any tags and manage them there at the same time. So he goes back to the tags section, adds the Postgres tag, and then he adds any other details that are required for students to be able to find that video, such as the week, the cohort, etc. Here he's going to add in a short description and then go into the timestamp editor. The timestamp editor enables students to be able to find specific sections of that video which are important. So from here, the way that he adds timestamps is by forwarding to a part of the video that he needs to add a timestamp for. And then once it's loaded up, you can then click add timestamp and give it a short description. And he can do this as many times as he needs to. And it's an easy way for him to add timestamps to a video without having to select too many items from the UI. Once he's finished, he clicks finished and those timestamps are saved. And then he has 3 sections below which allow him to add links to that video. So if he has any workshops, he can add those. If he has any slides, he can add those. And then finally, if he's got any other extra links, maybe for external sites or company sites, he can add those too. Once he's finished, he submits that video, heads back to the home page, and then he can now use a search on the left-hand side to find the video that he's just added and just check that everything's okay with it. So one thing that Jill did was add feedback for her use reduce video. He can view that here by finding the video. And then when he opens it and looks at the video viewer, he can then see the feedback that's been left by students on the right-hand side, which is anonymous from those students. The final things that he can do are if he needs to remove or manage any videos, he can put the editor, he can put the CMS into recap editor mode. From here, he can delete any videos that aren't needed any longer. And he can also re-edit any videos that need details changed on them. And that information will be put back into the form in full, along with the timestamps. And then when he's finished, he can submit those changes. So for now, that's the end of the demo from Jill and from James. And I'm going to pass you back over to Dan.
Cool, thank you, Will. So the main driving force for our project was our extensive planning. We used Disney ideation to form the backbone of our product choices, dreaming big and then looking into what would realistically be possible with the time given. We refined ideas creating Disney ideation into a minimum viable product. And we also put features from the Disney ideation that we didn't use in our MVP to one side for a possible minimum lovable product, or MLP. We also made diagrams to illustrate the architecture of our app and how our API would interact with the front end, as can be seen here.
When it came to our design, we went for a minimalistic look that would be reminiscent of the School of Code website. Once this was decided, we put a wireframe together using balsamic. When creating this, we referenced our MVP to make sure it matched all the criteria we had set out. We then adjusted our wireframes based on feedback we received from our target audience. This ensured we were staying on target with the needs of our consumer. Once we were happy with our wireframes, we then moved on to creating a more detailed design using Figma. This gave us a better visual representation of what our final product would look like. When it came to actually building the app, we used components from Ant Design. These components meant we had consistent styling throughout our whole app.
So, as we worked, we followed an Agile methodology, as we have done throughout our course. Daily stand-ups and end-of-day retros helped us understand where everyone was and what needed to be done. Then week-long sprints meant we could aim for a goal and then create a plan for the next week based on where we got to. We used a number of tools to facilitate our work: Notion, Trello, Jira, Slack, and Zoom. And then on GitHub, we branched from our dev branch when working on Jira tickets, and then we merged our stand-ups the next morning.
Some of the technology we used for the front end, we bootstrapped the application in React. It gave us a reactive and dynamic UI, which allowed elements to be updated on our pages without having to refresh the whole page. And design handled our UI. So our elements were all in the same order. They all had the same kind of design. It allowed us to quickly implement different elements without having to write more code. On the back end, we use Node and Express. That gave us an event-driven back end, allows us to have our APIs accessible by the front end. Node also allowed us to interact and communicate pre-authenticated with Vimeo API and with the videos that had been hosted on the School of Code Vimeo account. Firebase handled our authentication. And then on the back end, we used tools such as Postman to test our event-driven backend in Node, and also GitHub handled our collaboration and our version control between different segments of code.
So some of the key learning for us on this project was remote team working. We learned about the importance of know each other, and we created individual profiles right at the start, which detailed our strengths and weaknesses and goals for the project. We learned it was essential to use online tools such as Notion and Trello to collect and share ideas, especially as a distributed team. Mindful of the limitations of Zoom, such as lack of body language and non-verbal communication. And as a result, we learned to communicate more clearly and to ensure everyone understood the same technology. We learned to devote a lot of time to planning. We gave ourselves plenty of time to plan the project and to define our MVP. As a team of 6 with differing views, it could be difficult to reach a consensus. However, we didn't rush this process, we stuck at it, and this paid off once we got going with the implementation. It came together easily and we were all on the same page and had a clear understanding of what our solution was. We learned it was more effective to define roles and teams. We had a rotating weekly Scrum Goblin whose role was to keep the team focused and on track for that week's activity. And we often split into pairs and subgroups and delegated decision-making to those teams so that they could keep moving forward. We learned to take the time to really understand new technologies. This was essential to avoiding technical debt. It was quick to get going by studying sample code, but to really understand the technology, we had to read the documentation and understand the design philosophy of the tech that we were using. So moving on to our vision, our solution solves the problem we were presented with, and we have more features we'd like to add going forward. First of all, a comment system would allow boot campers to communicate with lecturers and other students, and playlists would allow coaches and users to make themed collections. Following that, greater personalization is quite important. We would offer user profiles, personalized homepages, and bookmark videos and personal notes. In addition, user timestamps could also be used for crowdsourcing of timestamps. More ambitious features would include inline viewing of slides, a code sandbox, and scaling up the system to allow for multiple cohorts of students.
So just to wrap up, a recap of recap, if you will. Our challenge was to improve the delivery of lecture resources to boot campers. And so the solution we've created is a media sharing platform where boot campers can search through and view lecture recordings. Each one is paired with the relevant learning resources, such as GitHub classroom links, lecture slides, and any additional reading material. By working in an agile way throughout our project, we were able to constantly evaluate and improve by adapting our app based on user and client feedback. One example of this is that our initial research showed that coaches wanted to have feedback on their lectures. So in response to this, our initial MVP included a star rating system. But on further discussion, we started to consider the possible negative psychological implications of a system such as this. And we decided that a more constructive solution would be an anonymous feedback system that's only viewable by coaches. And this was a really interesting lesson for us in remembering to consider all the different aspects and implications of what we're creating. So some of the key features that did solve major problems highlighted by our research are our extensive search and filter system, allowing the user to narrow down the selection of videos, a timestamp system, which lets users easily skip to important parts of the lecture, and for the coaches, a concise workflow for them to easily and quickly upload videos and give all the bootcamp information and also receive feedback. So thank you everybody for listening today. And if you have any questions, please get in touch with the School of Code.